A group of people would like to buy a vacation cabin for $600,000, sharing the cost equally. If they can find 5 more people to join them, each person's share would be reduced by $6,000. How many people are in the group? So first off, let's let X equal the number of people in the group. Since we're trying to find out the number of people in the group, once we find out what X is, we've solved the problem. But we need to come up with an equation involving X. So let's do that in step 2. And let's look at the information that we have. We know that we have some original cost per person. And let's figure out what that is. Well, we know that the original cost for the vacation cabin is $600,000. And we know there are X people in the group. So the original cost per person should be that total cost of the cabin divided by the number of people. We also know that there's going to be a reduction per person. So we can subtract the reduction that we have per person, and we're told that that reduction will be $6,000 per person if 5 more people join. So what is going to be on the right-hand side is the actual reduced cost. We have the original cost minus the reduction per person, and that will be the reduced cost per person. Well, the reduced cost per person is again the total amount that the cabin costs divided by the number of people. Well, we were told if 5 more people joined the original group, then the price would be reduced by $6,000. So we're going to divide by X plus 5 on the right-hand side. Now that we have the equation set up, we can solve it. It's a rational equation. We have a denominator of X and X plus 5, so we're going to multiply both sides of this equation by the quantity X times X plus 5. And on the right-hand side, I'll write it here, X times X plus 5. So on the left-hand side, when we distribute X times X plus 5 through, our first term, the X's will divide out, and we'll have 600,000 times the quantity X plus 5 minus, we have 6,000 times X times the quantity X plus 5 equals, on the right-hand side, notice the X plus 5 in the numerator and denominator divide out. We simply have 600,000 X left. So let's now clear the parentheses, and we'll have on the left-hand side 600,000 X plus 600,000 times 5 is 3 million minus 6,000 X times X is 6,000 X squared, and then minus 6,000 X times 5 is minus 30,000 X equals, on the right-hand side, we just have 600,000 X. Notice the left-hand side and the right-hand side both have 600,000 X. So we can subtract 600,000 X from both sides. They're no longer there, and we have what's left is a quadratic equation. So I have negative 6,000 X squared. I'm going to write this in descending order. I have negative 6,000 X squared. Then I have an X term of negative 30,000 X, and then a constant term of plus 3 million, and that's equal to 0. These numbers are a little bit large to factor, so one thing we can do is notice that each term is divisible by 6,000, and I'm actually going to go through and divide each term on both sides by negative 6,000 so that my X squared will have a positive 1 coefficient. So when I divide each term on both sides through by negative 6,000, I'll end up with X squared. I have negative 30,000x divided by negative 6,000, and that will give me a positive 5x. And then when I have plus 3 million divided by negative 6,000, that will give me a minus 500 equals 0. Now this is much easier to factor. So I can factor it by using an x and an x. And I know that 25 times 20 is equal to 500, so I'll use 25 and 20. I want 5x in the middle, so I'll use plus 25 and minus 20. When I set each of these factors equal to 0, if I set x plus 25 equal to 0, I'll get x equals negative 25. I need to discard this solution because I know that x is equal to the number of people in the group. Since I can't have a negative number of people, I'll just discard that first answer. And my second answer will be the answer. I'll put it over here on the left-hand side. If I set x minus 20 equal to 0, I'll get x is equal to 20. So therefore, I'm going to write the answer up here on the top in red. If x is the number of people in the group, we can say that the answer to our question is that there should be 20 people in the original group, such that if they add 5 more people to the group, there will be a cost reduction of $6,000 per person.